Hello and welcome to G Fun Facts Online, the show that unpacks the incredible science shaping our world. Today, we're talking about something straight out of a superhero movie. Imagine your phone screen cracking, only to watch the crack slowly vanish. Or a car that heals its own scratches after a minor scrape in the parking lot. This isn't science fiction anymore. This is the very real and very revolutionary world of self-healing materials. These are substances with the built-in ability to repair themselves, to mend damage, and restore their original strength. It's not magic, it's a brilliant combination of clever chemistry and designs, inspired by the master of self-repair, nature itself. So how does it work? Where can we find these materials? And what does a future full of things that can fix themselves actually look like? Stick around as we delve into the mending revolution. To understand how a material can heal, we need to look at its chemistry. Think of it like this. There are two main strategies. The first is called intrinsic healing, and the second is extrinsic healing. Let's start with intrinsic, which is basically the power from within. These materials have a built-in, inherent ability to mend themselves. The healing process is woven directly into their molecular structure. It's a bit like how our skin heals after a cut. You don't need to inject it with a healing potion. The repair mechanisms are already there, just waiting for a trigger. That trigger could be something simple, like heat or light. One of the coolest ways this works is through what chemists call reversible bonds. Imagine a Lego structure. You can break it apart and you can click the bricks back together. Some polymers are designed with chemical bonds that act just like this. A famous example is the Diels-Alder reaction. When you heat up a material made with this chemistry, some of its chemical bonds break. As it cools down, they snap back together, reforming across any cracks and effectively healing the damage. It's like hitting a reset button on the material's structure. Another nature-inspired trick uses disulfide bonds, the same kind of sulfur-to-sulfur links you find in proteins. These bonds can swap partners, breaking and reforming at room temperature, allowing a polymer to slowly flow and mend itself over a few hours. Then there are shape memory polymers. These are materials you can program to remember a specific shape. If you scratch or dent it, all you have to do is apply some heat, and it will pop back into its original smooth form, making the damage disappear. It's like the material has a perfect memory of what it's supposed to look like. Now what about the other strategy? Extrinsic healing. If intrinsic healing is like skin regenerating, extrinsic healing is like having a tiny first aid kit embedded inside the material itself. This approach involves packing a healing agent into the material, ready to be deployed the moment damage occurs. The most common way to do this is with microcapsules. Picture a material filled with millions of microscopic balls, each one filled with a liquid healing agent, kind of like a liquid glue. Throughout the material, there's also a catalyst scattered around, which is a chemical that triggers the glue to harden. When a crack forms, it rips open these tiny capsules. The liquid healing agent flows out, fills the crack, and as soon as it touches the catalyst, a chemical reaction starts. The liquid polymerizes, hardening into a solid that bonds the crack shut. It's an ingenious, self-contained repair system. An even more advanced version of this is inspired by the circulatory systems in animals. Researchers are creating materials with a network of tiny hollow channels, or tubes running through them, like veins and arteries. These vascular networks are filled with healing agents. When the material is damaged, the network pumps the healing agent to the site of the injury. And the best part? Just like you can get a blood transfusion, these networks can be refilled, allowing the material to heal itself over and over again. So whether it's through clever internal chemistry or a built-in first aid kit, these materials are programmed for recovery. The idea of self-healing might seem futuristic, but we've been unknowingly surrounded by it for a long time. Nature, of course, has been the champion of self-repair for millennia, from a lizard regrowing its tail to a tree sealing a wound with sap. Even some of our own inventions have had this ability by accident. Think of stainless steel. discovered back in the early 1900s. Its stainless property comes from a thin, invisible layer of chromium oxide that protects the steel from rust. If you scratch it, the exposed steel immediately reacts with oxygen in the air to reform that protective layer, instantly healing the surface. The first hint of intentionally creating self-healing materials in construction actually dates back to 1836, with observations of concrete that could seal its own cracks over time. But the modern field of self-healing materials really kicked into high gear much more recently. The true turning point came in 2001. A team at the University of Illinois, led by the late Scott R. White, a true pioneer in the field, developed the first polymer that could autonomously heal itself using that microcapsule system we just talked about. They demonstrated a material that could recover most of its strength after being broken. This breakthrough paper launched the modern era of research and inspired a generation of scientists. Since then, the field has exploded. The 2010s saw a surge in new chemistries, exploring everything from those reversible bonds to shape memory effects. By 2018, researchers were figuring out how to give self-healing properties to common, inexpensive plastics, bringing the technology closer to mass-market applications. And now, in the 2020s, scientists are pushing the boundaries even further, creating materials that can respond to multiple triggers and even mimicking the incredible properties of human skin. This is where it gets really exciting. Let's look at how this mending revolution is set to change our lives. Take the construction industry. Concrete is the most used material on the planet, but it has a major weakness. It cracks. Cracks let water in, which can rust the steel rebar inside, compromising the safety of bridges, tunnels, and buildings. Enter self-healing concrete. One of the most brilliant methods uses bacteria. Yes, bacteria! In this bacterial concrete, dormant bacteria and their food source are mixed into the concrete. When a crack forms and water seeps in, it's like a wake-up call for the microbes. They wake up, eat their food, and as a byproduct, they produce limestone, which is calcium carbonate. This limestone fills and seals the crack, stopping the damage in its tracks. A pilot project in the Netherlands used this technology on roads and found it significantly reduced maintenance costs. Another study on a bus lane at Schiphol Airport showed it could extend the design life by 15 years and cut life cycle costs by a third. Companies are already selling these products today. Now let's move to your driveway. Scratches on a new car are always painful. But what if they just vanished? The automotive industry is all over this. Nissan was one of the first with its Scratch Shield paint, a clear coat that uses a special elastic polymer to slowly flow back into place, repairing minor scratches over a few days. More recently, researchers in Korea developed a coating that uses sunlight as a trigger to heal scratches in just 30 minutes. Imagine parking your car in the sun to fix those annoying little marks. And it's not just paint. Goodyear is developing self-healing tires that can automatically seal small punctures, which would be a huge boost for safety and convenience. In the aerospace industry, safety is everything. Modern planes use super strong, lightweight carbon fiber composites. But these materials can develop tiny micro cracks that are hard to see but can grow into major problems. Self-healing composites are being developed to autonomously repair this internal damage, extending the life of aircraft and making flights even safer. Our digital world will benefit too. We all want flexible, wearable electronics, but bending and stretching can cause damage. Self-healing polymers are being used to create circuits and sensors that can repair breaks and restore electrical conductivity. Researchers have even made self-healing batteries that keep working even after being cut or punctured. But perhaps the most profound applications are in the biomedical field. Scientists are creating self-healing hydrogels, which are squishy, water-filled polymers that are very similar to our body's own tissues. These can be used as advanced wound dressings, especially for joints like knees and elbows that are always moving. The dressing can heal itself if it tears, all while providing a perfect healing environment for the skin underneath. These gels can also be used for drug delivery. You could inject a drug-filled hydrogel into the body, where it would form a stable depot, slowly releasing medicine over a long period. And in tissue engineering, these self-healing materials can act as scaffolds, providing a stable regenerating structure for new cells to grow on, helping the body to rebuild itself from within. Of course, a world filled with self-healing everything isn't here just yet. There are still some hurdles to overcome. One of the biggest is cost. Creating these complex materials is often more expensive than making traditional ones. But just like with any new technology, as manufacturing gets better and scales up, the costs are expected to come down. We also need to make sure these materials can perform reliably for a long time and under extreme conditions, like very high temperatures or harsh chemical environments. We need to be certain that the healing ability doesn't fade away after a few years or a few repair cycles. Despite these challenges, the future is incredibly bright. Researchers are already working on the next generation of materials. Imagine a material that can respond to multiple triggers. One that heals with light, but can also be triggered by a change in pressure. Or even smarter materials that integrate sensors. They wouldn't just heal damage. They would sense it happening in real time and maybe even adapt to prevent future damage. Scientists are also drawing more inspiration from nature to create materials that are not only self-healing but also sustainable and easily recyclable. And with advanced manufacturing like 3D printing, we can now create incredibly complex internal vascular networks for healing, opening up designs that were once impossible. The science of self-healing materials is a beautiful example of human ingenuity learning from the master craftsman, nature. By understanding and mimicking the chemistry of repair, from reversible bonds to biological systems, we are creating a new class of materials that can defy decay. The potential is staggering. A future with more resilient cars, more durable buildings, more reliable electronics, and more effective medical treatments. A future where our creations have a longer life, reducing waste and paving the way for a more sustainable world. While the road ahead has its challenges, the pace of discovery is breathtaking. The mending revolution is well underway, and a future where the things we build can fix themselves is no longer a fantasy. It's a future that is healing itself, one molecule at a time. Thanks for tuning in to G Fun Facts Online. Join us next time for another deep dive into the science that's changing everything.